We're going to present the third stage of our project at Calculus 3. Our team is made up by Arturo Fraga, Samuel Vélez, Jafet Chávez, and Rafael Galvan. First, our team choose the function x squared y squared minus 2x squared y minus 4x y squared plus 8xy, whose graph is represented in these images below. And as we can see, it has at least one local maximum and 4 saddle points, which this means 5 critical points in total. But how we obtain those? With the partial derivatives, as we can see right here with respect to x and y, and then to obtain which are local maximum, local minimum, or saddle points, we evaluate the 5 points in our second partial derivative to obtain that we have 4 saddle points and 1 local maximum.
The first step to know how to use the contour map is to know that the local maximum and minimum points are always going to be contained by concentric contours, just like these ones, and also that the saddle points are located where the contours intersect, just like these points. And with this information, we can easily identify that in this graph we have 4 saddle points and 1 maximum point because it's contained by the concentric contour, and here we can see that it's a local maximum point. And also we can use the contour map to explain the behavior of the graph. Just by looking at it, we can see that at these points, at this and this, the graph is going up, and also that at the part where we can see blue, the graph goes down, just by looking at the contour map.
So this is part C. To find the tangent plane at a point, we need to pick a point. The point we chose was 3, 1, 3. Next, we need to find the gradient vector to f, as shown here. After that, we need to evaluate the gradient vector at our selected point. We end up getting -2, 0, -1. Now we have to substitute all of our values into the equation for the tangent plane, and we end up getting -2x plus 9 equals z as our equation for tangent plane. To find the normal line, we need a point and a parallel vector. Since we already have those two, we can simply substitute for the values into the normal line equation. And these are our parametric equations for the normal line at the point 3, 1, 3.
Once we have found the equation of the tangent plane and the normal line, we use GeoGebra to graph them. And this is the normal line, and this is the tangent plane.